The indoor and outdoor motherboard of the Daikin Mini Split air conditioner has come to us for repair. I have turned it on to show you the problem. The fan motor started for a while and then stopped. The blue light has started to blink. First, I am finding the error code in this unit. When I checked it with the remote, it showed U4 error. The U4 error is the serial communication problem between the indoor and the outdoor unit. In this situation, the first thing to check is the outdoor unit. I will check the electricity on its terminals. I will put the multimeter in AC mode. I will check whether the electric supply is flowing to these terminals. 227 volts are flowing through the 1 and 2 number terminals. And still, the outdoor motherboard is not working. Next, I will check the 2 and SIG terminals. I will put the multimeter to DC volts. And check whether the signals are generated on these terminals or not. No signals are generated on these terminals in DC mode. I will put the multimeter to AC mode to check what it shows on these terminals. It is showing the same 220 volts here, and it does not show anything on the DC voltages. The signals are not generated between the indoor and the outdoor motherboard. Right now the electricity is flowing towards the outdoor motherboard. That is why we will check the outdoor motherboard. But in case if the electricity is not passing through the outdoor motherboard, so let me tell you its reasons. If this electric wire goes bad, the outdoor and indoor motherboards will still not communicate. If the electricity does not pass to the outdoor motherboard and the indoor motherboard is turning on, then this relay could go bad. It could get stuck internally. And often, by changing the relay, this problem gets fixed. The main electricity in this mini split is from the indoor. You can see L and N are written with these terminals. The supply from this relay goes toward the outdoor unit motherboard. In some mini split air conditioners, the supply is from the outdoor unit. This relay is not present in the indoor unit. If the indoor motherboard's communication circuit goes bad, this problem can still be shown. In this motherboard, an optocoupler and a resistor are installed here. Some diodes and a second optocoupler is installed at the back side of the motherboard, which works for communication. If it goes bad, still the unit will make this problem. In our case the electric is passing through the unit, but the outdoor motherboard is not working. The problem right now is in this outdoor motherboard. This Daikin air conditioner outdoors depends on 2 control boards. The one is the filtration PCB for electricity. The other is this communication circuit. This is its main control board. IPM is installed on this board. I will check the fuses in this filtration PCB board. This first fuse is 15 amperes. I have set the multimeter on continuity mode to test it. This fuse is fine. It has no issue. This second fuse is 3.5 amperes. This fuse is also fine. It also has no issue. I will understand this smaller motherboard first. It will be easier to work further if we first understand the smaller PCB. This white wire is the neutral wire in this motherboard. The black wire is the phase wire. The electricity from this main fuse passes toward the line filter. The neutral trace directly moves forward. The phase is also moving further. But it is attached to this PTC sensor. The line trace is also attached to this fuse. The line trace from the PTC sensor is attached to this relay. This relay is attached to this PTC sensor in such a way that its wire traces are moving towards the communication circuit. As how much I have studied this board right now. This brown wire is attached to the fuse. This wire has a jumper wire installed on it. This jumper wire connects it back with this fuse. And the trace wire from the fuse moves towards this gray wire. This gray wire is the phase wire, and the neutral will flow towards the yellow wire. 220 volts should be passing across the connector of these wires. This wire is connected to the main motherboard S12 connector. This means this power supply is used to power the SMPS of the main board. The other wires attached to the main board are these. Now this white wire is the phase wire here. The blue wire is the neutral wire. I will remember it because it is important. As if the polarity of the phase and neutral are misplaced, it could cause problems. The blue and white is written on the terminal of the main board. These 2 wires are connected to the bridge rectifier, which converts the AC electricity to DC electricity, which passes the electricity further to the capacitors and the IPM. I will have to determine which outdoor motherboard sections are faulty. I think the SMPS will work first on this motherboard. I am now supplying electricity to the motherboard. I will test whether the electric supply is reaching this connector or not. 236 volts are flowing on this connector. This means this is fine. I will check its SMPS, as when it turns on first, the rest of the functions in this motherboard operates. The reactor or the inductor is installed inside the main motherboard. I have supplied electricity to this motherboard. I will check the DC supply on the rectifier. 156 millivolts are flowing here. It should show 300 plus volts here. I will put the multimeter to AC electricity and check whether the AC supply is flowing through this rectifier or not. Only 1 volt is flowing through the AC side of the rectifier pins. This means the voltages are not flowing toward this rectifier. This is the line filter in this main motherboard. When I move forward, a 51 ohms resistor is installed. Let's check the line filter in this resistor. I have set the multimeter on the ohm meter. 0.8 ohms resistance is on the line filter. The other side of the line filter is also 0.8 ohms, which means it is also fine. Next, see this trace here. This trace is directly attached to the phase side of the rectifier. The neutral is installed here, moving towards the rectifier's negative pin. The power resistance is installed with the negative trace of the rectifier. The resistor value is 11.45 mega ohms. This resistor may be bad, making it not pass electricity through the rectifier. I passed electricity through the motherboard. These SMD resistors went bad. And the 51 ohms resistor I changed also went bad. I will check this rectifier. It is showing a 0.8 voltage drop. It is also showing a 0.8 voltage drop on the second pin. This third pin has 0.291 voltage drop. The polarity is attached to the positive. It should not have shown the voltage drop here. Now, I have placed the negative probe with the positive pin of the rectifier. It is still showing values on all the pins. It should not have shown us a voltage drop, as I have changed the polarity of the probes. This means this rectifier is short-circuited. Now off the camera, I did a lot of work on it. Let me show you what modification I made to this motherboard. I have changed the bridge rectifier. This was the number of the old bridge rectifier of 1 ampere. I have installed a 2 amperes bridge rectifier here. The amperage will make no such difference. The resistors were SMD 2 ohms resistors. I have installed the dip resistors in place of the SMD. Let me show you the main work I did on this motherboard. You should have the information about that. I didn't have a new 3 watt 51 ohms power resistor. I installed another resistor on this board, which I removed from a scrap board. But this 5 watt resistor burned out. In place of the power resistor, I have installed 2 power resistors. Both are of the 100 ohms. I have installed them in parallel. These will work as 50 ohms resistors. It will work as 4 watts. Other than this, you are seeing this switching IC A6061H. I have installed this IC in place of the old IC installed here. I have removed the capacitor from C21. Let me explain why I did it. The original switching IC installed in this motherboard was A6251H. I didn't have this number, so I installed a replacement IC in place of it. That is why I removed the capacitor and soldered its pads. The 2-number pin of this switching IC is a brown in and brown out detection voltage input, used for under voltage protection. A resistor or a capacitor can be used, but I have soldered the pin of the capacitor directly. I am now checking it on the series board, to avoid the motherboard from causing any problems. I have switched on the electricity by pressing the button. The motherboard has been powered on. The LED light has started to blink. Now I will power the motherboard on normal electricity. The motherboard has started to power on. I have attached the indoor and outdoor motherboards together. The indoor blower motor is working fine. The outdoor fan motor has also started working. The compressor has also started to work. This is how I have fixed this problem. Click on the left or right thumbnail to watch our next videos. and subscribe. Thank you.